So today we're going to start on Introduction to Functions. Okay. Some of it will look familiar, some of it may look a little new, but it's all the same general idea. Okay, so let's say, for example, we're all familiar with, let's say, y equals 7x plus 2. That just shows the relation between x and y. When x is a value, y is a certain value. When x is a different value, y is a different value. So it just shows the relation between x and y values. And that relation is usually set up as an ordered pair. It's a set of ordered pairs. X comma y. Okay, so for this one, y equals 7x plus 2, you have the relation of 0, 2. Which is basically when x is equal to 0, y is equal to 2. Or you have 1, 9. When x is equal to 1, y is equal to 9. Okay, so you literally have an infinite number of possible relations. Okay. Now the domain of that relation is every possible x value. Any x value where you won't have a denominator of 0 or we won't have a negative square root. So all of your real possible x values. Set of all possible x values. And your range is just every possible y value. So within that domain, every possible y value is your range. Set of all possible y values. All right, so let's say for our first example, what if we wanted to determine the domain and range for, let's say, for problem A? We have the set of ordered pairs 2, 3, 2, 4, 0, negative 1, and 3, negative 1. And for problem B, you have negative 3, 1. You have negative 2, 1. You have 0, 1. You have 1, 1. And you have 2, 1. So you can kind of think of those just all points on a graph. Okay. So for problem A, if we wanted to look at our domain, remember that's just all possible x values. Then that's just going to be, you have 2, you have 2 again, you have 0, and you have 3 for all of your x values. Because remember, it's just in the form of x comma y. So even though 2 appears more than once, you only write it down one time. So you have 2, you have 0, and you have 3. That's supposed to be a bracket, but I mean, not a bracket, a brace. There we go. And your range, just all possible y values. Okay, so you just do the same thing. You look at all of your y values. You have 3, you have 4, you have -1, and you have -1 again. Okay, so -1 you only have to put in this set once. So you have 3. You can put them in numerical order if you want to. You don't have to. So you have 3, 4, and -1. Okay, so we do the same thing for B. And we kind of give that a little bit of space. Your domain for B, again, that's just all possible x values. You have -3, -2, 0, 1, and 2. Now for your range, again, it's just every possible y value. You have 1, 1, 1, 1, and 1. So in this case, your range is just 1. So even though it repeats, you only have to put it in there one time. Okay. Any questions on this one? All right, I'll leave that up there. Yes?
So the order in which you put them in the braces doesn't matter?
It doesn't matter. I don't think it matters on the homework, but with Newton, they may be picky, but it shouldn't matter.
Okay.
All right, leave that up for a few more seconds. All right, so let's say for our next example, if you want to find the domain and range for, and this time, we're going to set up 2 tables. Okay, where this are cities, and this one is our population in thousands. Ooh, bless you. Okay, so we have Lubbock, Texas. We have Colorado Springs. And might as well separate those. We have Omaha. And we have Sacramento. Okay, on this side, we have 370,000. We have 197. We have 404. We have 445. We have 206. Okay, so what if Lubbock went to 206? Colorado Springs went to 370. Omaha went to 404. And Sacramento went to 445. Okay, so this would be your input. And this would be your output. Okay, so to find your domain and range, your input is really just your x value. So you have y equals something. If you input x equals 4, then you get an answer. If you put in x equals 5, you get an answer. This is the same thing. When you input Lubbock, your output is 206. Okay, so we think of this as your x values, and this as your output as your y values. Okay, so your domain is going to be Lubbock, Colorado Springs, Omaha, I'll put it under here since we're running out of room, and Sacramento. Close that up. And your output are all possible y values. Well, your range is all possible y values or all possible outputs. So you have 370. You have 404, you have 445, and you have 206. Okay. Now we didn't put 197 because we can only match our range with our domain. If the range doesn't fall within the domain, then it's not a part of our range. So even though 197 is an option, it's not falling within our range since it's not matched up. Now if we had, another city down there matched with 197, then it would fall in our range. All right. Does that make sense? All right. Any questions on this one? All right. I'll leave that up there for a few more seconds. You know what? I think I passed around the wrong attendance sheet. Sorry. I think I passed it around for 405. I know. Hey, I'm looking at it. Okay, that one should have been passed around. So you can ignore that last one. Is there? Yeah, completely different. It's not that far off. It's not that far off. Yep. That's just for that room because I go immediately over there. So, all right. Now we're going to look at the actual definition of a function. We know how a function works. When you plug in one value, you get another one, you plug in different values. But the actual word-for-word definition of a function, it's a relation where every first component of an ordered pair which is just a fancy way to say your x value, corresponds to exactly one second component. Actually, let me kind of emphasize the exactly one. And that second component is just another way to say y value. Okay. So in other words, that just means every x has exactly one y. Has has exactly one y value. Okay, so let's say, for example, let's say if we wanted to determine if the relation is a function. Okay, so for A, what if we have -2, 5? What if we have 2, 7? What if we have -3, 5? And 9, 9. And for B, what if we have -3, 2? 0, -2. Uh-oh. Yep, -2. 0, 3. 1, 5. And 6, 6. Okay, so that's just our group of points on a graph. Okay. Now with A, the first thing you want to look at are all of your x values. -2 only has one y value, that's 5. You don't see it appear anywhere else. 2 only has one y value. You don't see 2 for any other y value. Same with -3, and the same with 9. So A is actually a function because each x has exactly one y. Since each x value has exactly one y value. Okay, so we know that one's a function. Now with B, if we look here, we see -3 has exactly one y value. You don't see it pop up anywhere else. But if you look at x equals 0 here and x equals 0 there, you have two different y values. Okay, so this one's not a function. Okay, not a function since x equals 0 has two y values. Oh, bring that up a little bit. Okay, so we have 0, -2, and 0, 3. So this is saying that when x is equal to 0, y is equal to -2. But this is saying that when x is equal to 0, y is equal to 3. Okay, so they can't be true and both be true and call themselves a function. All right. Does that make sense? All right. All right, leave that up for a few more seconds. All right, so let's say if we have the example determine if the relation is a function. let's say for A, if we have 1, 1, 2, 2, -3, -3, and 0, 0. For problem B, we say of the point, should be 11, 6. -1, -2, 0, 0, and so we have -1, -1. And for problem C, so you have -4, 8, -2, 5, -1, 8, and 1, 4. Okay, so for A, you just look at all your x values. 1 only has one y value. Same with 2, it doesn't appear anywhere else. Same with -3, it doesn't appear anywhere else. Same with 0, it doesn't appear anywhere else. So it is a function. Every x has one y. Okay. So we do the same thing for B. You have 11. You only have one y value for 11. It doesn't appear anywhere else. With -1, that actually appears a second time with 2 different y values. So that one's not a function. So it's not a function since x equals -1 has 2 y values. And that's your -1, -2, and -1, -1. Okay. Now C is just a little bit different. Okay. So we see here that -4 has only one y value. -2 has only one y value. -1 has only one y value. But 1 has only one y value. But if you notice for these two, your y values are the same. It's still a function because remember, the definition of a function is every x can only have one y. Y's can have different x's all day. So you have, if all of these were 8s for y values, it would still be a function. So it's just the x that has to follow that only one y value. It's not the other way around. Does that make sense? Okay. Since every x has one y. Okay. So quick note, y values can have different x values. And still be a function. Okay, and we'll just point out those two. So we have -4, 8, and -1, 8. That's kind of definitions of that. All right, so any questions on this one? leave that up for a few more seconds. Right. Let's say if we wanted to determine if the following are functions. Okay, so let's say for problem A, if we have the table with A, B, C, D, and E. And let me clean that up a little bit. There we go. And let's say for this table, we have red, blue, green, orange, and yellow. Okay, so A will take that to green. B will take that to red. C will take that to red. D will take that to orange. And E will take that to yellow. Okay, where this is our input. And this is our output. And for problem B, again, we'll set up our table. We'll have this one as 1, 2, 3, and 4. And we'll have A, B, C, and D for our output. Okay, so let's say we take 1 to B, 2 to B, 3 to B, and 4 to B. Yes.
Is he pointing at red or blue?
Which one?
And letter A.
A is going to green, B is going to red, C is going to red.
Okay.
Okay. Yeah, I can see how that can be confusing. Let me make that a little longer. Going to shut off in like a minute, so let me go ahead and